The atomic age has moved forward at such a pace that every citizen of the world should have some comprehension, at least in comparative terms, of the extent of this development, of the utmost significance to every one of us. Clearly, if the peoples of the world are to conduct an intelligent search for peace, they must be armed with the significant facts of today's existence.
Our journey actually started very early. President Eisenhower presentation in United Nations General Assembly, December 1953.
We had the first research reactor license of any reactor in the United States.
President Dwight Eisenhower visited the university to visit his brother, came to the reactor. It wasn't completed.
And Red woke up and he says, "Wonderful, wonderful, wonderful."
My name is Kenan Ünlü. I am the director of the Radiation Science and Engineering Center, and also I'm a professor of the nuclear engineering at Penn State. Reactor construction at Penn State started in 1954.
There's another story that I should tell. My name is Edward Clevens. I was Associate Dean for Research in the College of Engineering. We had the first research reactor license in the United States, reactor license R2. Reactor license R1 was for a reactor that was at North Carolina State that had already been shut down by the time we were issued our license. Theirs never started up again. We have the oldest licensed reactor operating in the United States.
Breazeale, I think, had given a talk or written something about, he thought that the swimming pool type reactors could be a very important tool for universities for research. So he talked to Walker about that. Walker was very interested because at that time it was the Penn State College, it was still State College, and research was not something, very strong at Penn State. So he thought this might be a way of getting Penn State on line with research. So it so happened as a side effect, there was a coffee shop at the basement of Old Main many, many years, and it had built up a pool of money, about $250,000.
They used to play poker over at Milton Eisenhower's place. And at one of the poker meetings, Milton announced that he was going to close the cafeteria down in the basement of Old Main, and he had $250,000 left over. Did anybody have any ideas about what to do with it? It turns out that Eric Walker was the head of a group studying manpower in the United States, and he had been to Oak Ridge for a meeting. And at Oak Ridge, he had met Bill Breazeale. And Breazeale was the one who had designed and built the bulk shielding reactor.
And Walker said, "Give me till 9 o'clock tomorrow morning, and I think I'll give you a very interesting proposal." So he got Dr. Breazeale, who was at Babcock and Wilcox Company at that time, to come up with a quick proposal. So Walker the next morning met with President Milton Eisenhower, told him we could build this reactor.
Milton Eisenhower met with him, ended up recruiting Breazeale to come to Penn State and join the faculty in electrical engineering, even though he was a physicist, and he would be teaching reactor physics at Penn State, which he did for a number of years. Eric Walker asked Bill Breazeale how much it would cost to build a reactor like that at Penn State. And Breazeale said about $250,000.
The facility was actually built for about $308,000, if I remember. But the reason it was even brought at that price because a number of professors. They welded the tower together and all those things that were needed to.
And civil engineering would help design the location, and electrical engineering would help design the control system. In 1955, Dwight Eisenhower came to give the address for the graduates. He got recruited by his brother Milton to come up to Penn State.
This is President's speech at the commencement. He repeated the same idea at the commencement. He delivered his speech at the Atom for Peace. He's saying that nuclear technology is not the nuclear weapons. There are also other applications. We don't want to hold the monopoly on this, and we would like to share all the knowledge with the entire world. That's a great vision and then great initiative.
There's a picture over at the reactor that shows Dwight Eisenhower looking into the reactor with Milton and Eric Walker. And Dwight asked where he could push the button to start the reactor.
President Dwight Eisenhower asked Walker, "Where's the button I push to start this thing up?" And Walker said, "The button you have to push is in Washington because they haven't shipped the fuel on them."
He is pushing the button to start the reactor, but that particular time the fuel was not in. And after he found out that 2 weeks later, fuel arrived.
So these were highly enriched, weapons grade uranium in them, but the next day or two, in a pickup truck, I'm told, highly enriched uranium was shipped to Penn State, so they had fuel to start up the reactor. So they're just endless stories that can be told about the facility in the early days, from anything from turkey flies to algae, to, all kinds of interesting stories if you were involved. The facility was the reactor bay, the electronics shop, one room where director and assistant director could sit, and the beamhole laboratory. And halfway down, two physics professors put up the block wall to make the laboratory there. Tiny little laboratory. And some of the things that I'm proud of, yes, we put in the hot cell. We put in the large aluminum tank so we could drain the pool, clean it, and so forth, or repaint it. The Cobalt 60 facility.
This is another building which we have the Cobalt 60 gamma source. Later on, we have also some gamma irradiator, which is dry irradiator. So we have, besides the reactor, we have also 2 gamma irradiation facilities. 1965, Penn State decided to change the reactor core to TRIGA core.
We needed to go to a megawatt, and the enticement of ability to pulse was something new.
TRIGA is Training Research and Isotope General Atomics reactor. Then it uses actually 28% fuel. So therefore the low enriched fuel. In other words, Penn State is also not just the first licensed reactor in the United States, and also the first conversion reactor. However, there was some drawback for this change. The original beam lines or the beam ports misaligned with the new core arrangement. Only one of them was looking at the center line of the core. So this actually hampered our research effort dramatically because we were only using one beam tube since 1965. And this one is, I say that this is once in a lifetime picture. Before we putting the core in place, picture is taken. Core is placed right here. These are the 5 beam tubes providing neutrons to these beam ports. One of the beam port will have the cold neutron source. Cold neutron source is if you put a cold moderator around 20 Kelvin, when neutron pass through, neutrons change their energy, and when energy shift, the wavelength increase, so that these neutrons can be carried out for greater distances by using neutron guides, supermirror neutron guides with almost 95% efficiency. This is the layout which we are going to be placing at the Penn State. About 2 years ago, I was at Vienna and invited to give a talk about the cold neutron source. And during that time, I met with this German colleague, and then he said that Berlin reactor is actually decided to shut down because they built a much better or bigger reactor at the Munich. So therefore, some of the equipment may be available. This is called the small angular neutron scattering facility.
The people we had at the reactor, best epitomized by an old grouchy chemical engineering professor that finally came for a visit to the reactor. And when he left, we heard him grumble, just a bunch of young kids in lab coats.
I'm just hoping that we'll get some more of them built in the United States, because they don't produce carbon dioxide. And it would be very good if we could just the highest percentage of non-CO2 generation is with nuclear power right now in the United States, and I expect that to last for quite a while.
It's nice seeing and talking to you again, and I think of the reactor a lot. It's been an interesting life. You know, I'm going to be 95 on November 30th. And it's a new world when you enter 90s.
Will remain one of the major leaders of the revitalization of the nuclear science and engineering in the United States for years to come. I wish that you will be able to come and see in person our facilities. I hope that that will happen sometime in near future. If you do have any question, please don't hesitate to visit our webpage. Thank you.